Hello, my name is Anthony Cruz, and today we're going to go through a wind tunnel flow simulation assignment. So, first thing we're going to want to do is we're going to want to create our geometry. Alright. So, to create our geometry, here we go. Essentially, what we did is we created the sketch here. Um, you want to make sure that your angles are correct. Right here, the most important part is that this angle right here does not exceed 5% so that you don't have any backflow in the system. So this is probably the most critical part of your design. You want to make sure that everything else is even. So then once you go ahead and you make all your dimensions and whatnot according to the wind tunnel that you want to design with, the next thing you want to do is you want to go ahead and generate that, and boom, so we're good here. We have our model now. Boom, cool. So now we're gonna go back to our main screen and we're gonna update our mesh. So for our mesh, I did a simple automatic mesh and then a body sizing mesh. Put it to about 5 millimeters. Selected the entire body and created that mesh. Then the next thing I went ahead and did is created my name selections. Velocity inlet for the left one, pressure outlet, our top wall. When it went along this entire top wall, bottom wall along this entire bottom wall, and then our object. You can put whatever object you want to see the flow simulation in here. Um, so once you go ahead and we generate that, once it creates our mesh, it should be a good mesh. I'll show you guys the mesh. Show mesh. So here you go. As you can see, we have a very fine mesh, and it's not quadrilateral around here because it's trying to conform to the star. So anyways, we're gonna move on to the next thing, our setup. And here in our setup is where we're gonna set up everything. Where we're gonna find our velocity contours. We're gonna find every contour that we can in here because that's what we want to do. It makes it much easier, and I'll show you guys how to do it. So our models, we want to do a viscous model. I went with a K epsilon flow, kept everything standard wall functions, standard model. Went ahead and hit OK. So the next thing we want to move on to is our fluid. Make sure there's air. Make sure all the properties of the airs that you're testing with is okay. Then we went into the boundary and conditions. Make sure that our inlet velocity is marking the inlet side. Actually, let me stop showing this. Okay. Well, anyways, so we go ahead and click our inlet velocity, and what we want to do is we want to alter it. For this specific project, we're choosing 10 meters per second, just to keep everything consistent. Internal, our outlet, we want to make sure our pressure outlet set to 0, so it could be just 0 pascals. Our gauge pressure is constant within and without. For our walls, we got our bottom wall, our top wall, and then of course our object, because we're gonna treat our object as a wall, just so it can have like a nice smooth or just that's just the way that we're gonna use this specific simulation for now to keep things very simple. And once we set up all of our conditions, we gotta initialize. Once we initialize and everything's okay, we want to go ahead and run our calculations. So once we finish initializing, we calculate, and we're gonna go ahead and let it, calculate. It's gonna go through a lot of iterations, and whatnot, but as it goes and does its iterations, we will let that go, and we want to go. Can I close this calculation? So once we finish calculating there, what we're gonna want to do is creating our contours. So to create your contours, very simple. You create new contour. You name your contour, and so if you want to do pressure, go ahead and click pressure, total pressure, dynamic pressure, static pressure. Whatever you want to calculate, you select that. So for this one, we'll put static pressure. And then for the surface that we're going along is the surface body, the surface that we created. So that's what we're testing. We're not testing the walls or anything like that. We're gonna save and display, and this is our result. Um, so that's kind of what you wanna get at, and then we can change it to velocity, get the magnitude of velocity, and this is what we're gonna look like. So you can go ahead and play around with this. For temperature, you get static temperature. In this specific example, in a wind tunnel, we're always going to have a constant temperature throughout, solely because there's no aspects of changing with the temperature in here. Everything that's getting affected is velocity and pressure, and that's one thing that we have to understand is that temperature is in no way being affected by this. Um, for one of the example, when we want to show our plots, um, one of the things that we want to do is we want to go into the surface and create a line. This is for our plots. So we're gonna create a line, and for the purpose of just showing, what I'm gonna do is I'm just gonna select 2 points, which are just about in the middle, just for the purpose of learning. So created my line, color line 0, and then we'll close that. So now we have surface, we have line 0. You can't see the line, but we'll be putting it to use in a moment. So once we have our plots, go to our XY plot. We're gonna create a new one. Again, you want to create it. You want to call it whatever you want. If we're calculating static pressure, we'll call it static pressure plot. Get rid of the one real quick. So boom, pressure, static pressure, and then for the surfaces where it gets tricky, we want to unselect all of these, and the only thing we want to see is that line. We want to see the pressure along that line for our chart, and so we go ahead and save that, close, and so this is the pressure along that. At this position we have our star here, so that's why we have this breakage. But if we didn't have our star, it'd be a more linear curve, not a linear curve, but a consistent curve. We wouldn't have the break because of the actual test subject. So that's one thing that's important to note. But that is how we go ahead and do our plots. And so once you have all your plots, our results I will show you now. So these are our static pressure, velocity. All of these are for with no test subject. This is just the wind tunnel on its own. We have our static pressure, velocity, magnitude, total static temperature. Our total pressure stays pretty much constant as well. Total temperature constant. Our dynamic pressure, a great thing that we see here is that here we have the atmospheric pressure is pretty much equal to the beginning and the end of it. And in our test subject, we have a very consistent, um, new pressure that stays consistent without, so that we know that when we put a test subject, there's no variations, and then